Welcome back. In the previous lecture, we manually built our SparkSession and learned how the driver acts as the brain of our cluster, handing out tasks to our worker nodes. We have the engine humming. Now it's time to talk about languages. A lot of people think that because Databricks notebooks are polyglot, or rather multi-language, it just means you can write a Python script in one cell and a totally unrelated SQL query in another cell. But it is infinitely more powerful than that. Because a SparkSession acts as a universal gateway, we can actually define data in Python, pass it directly to the SQL engine to be queried, and pull the results back into Python, all without ever saving a single file to a hard drive. In this lecture, we are going to perform the ultimate Python to SQL round trip. Now, in a standard programming environment, a SQL engine has absolutely zero visibility into your local Python variables. They live in different worlds. So let's prove how the SparkSession bridges this gap. First, let's manually create a tiny data set in Python. Now, in your next cell, I'd like you to type the following code and Shift Enter to run the code. All right, so let's break down exactly what this code is doing. First, it creates mock_data, which is just a standard raw Python list containing a few rows of dummy data. Spark.create DataFrame takes that raw Python list and converts it into a massive distributed PySpark DataFrame. The second argument ID project name assigns the column names. Finally, display renders the data frame into the beautiful interactive HTML table that you see on screen. Take a look at that output table. We successfully created a 3-row PySpark data frame. You can clearly see our ID column and our project name column populated with project alpha, beta, and gamma. But right now, this data frame df_Python only exists in the Python memory space. If you created a new cell and typed %SQL and tried to run a select all from df_Python, it would instantly crash. The SQL engine would say, I have no idea what df_Python is. We need to introduce them. We do this by creating a temporary view. Think of a temp view as a temporary name tag that we stick onto our Python data so the SQL engine can easily spot it. So in a new Python cell, run the single line of code which I am going to paste on a new cell and then Shift Enter to run. All right, so when you run this cell, it will happen instantly and won't output anything visually. However, what this command actually do? This is the magic bridge. It takes your Python data frame df_Python and registers it in the Spark's internal database catalog under the temporary name project_codes. Without this step, the SQL engine would have absolutely no idea your Python data exists. The command is the handshake. It tells the SparkSession, hey, take my Python data frame and register it in the temporary catalog under the SQL table name project_codes. Now let's switch languages using our magic command in the next cell. Now, in a new cell, I'd like you to type the code that I'm going to paste in the cell, and I'd like you to do a Shift Enter to see the result. Now, the %SQL magic command tells the Databricks notebook to stop reading Python and treat the rest of the cell as pure SQL. It then queries the project underscore code table we registered in the previous step, filtering out the first row where the ID was 1. Take a look at the output. We get a neatly formatted table showing exactly 2 rows, project beta and project gamma. We have successfully queried our Python variable using Apache Spark SQL. But look very closely at the small text printed right above the table. It says underscore SQL df PySpark.SQL.connect.DataFrame. This is a massive hint for what we're about to do next. Now, what if we want to take the filtered result of that SQL query and keep working on it back in Python? Do we have to write it to a database first? No. Databricks has a hidden feature for this. Every time you run a %SQL cell that returns data, Databricks automatically captures that output and temporarily stores it in a special Python variable called underscore SQLDF. So in the very next Python cell, I'd like you to type the code that I'm going to paste in a new cell. And then Shift Enter to run. Now look at the output. First, we see our printed statement, welcome back to Python, successfully executed. Now, right beneath that is our interactive data frame table containing the exact same 2 filtered rows, project beta and project gamma. Now, by running final underscore Python df assigned to underscore SQLDF, we are safely copying that captured data into a new variable of our own naming so that it doesn't get overwritten the next time we run a SQL cell. You now have a standard PySpark DataFrame final underscore Python underscore df containing the filtered result. Now ready for any complex Python logic or machine learning libraries you want to throw at it. Now here's an important warning. The underscore SQLDF variable is incredibly volatile. Every time you run a new SQL cell anywhere in your notebook, underscore SQLDF gets overwritten. Always assign it to a safe named variable immediately, exactly like we did here. Now let's recap this incredible round trip. We created raw data in Python. We gave it a name tag using create or replace term view. We queried and filtered the data using SQL. We pulled the filtered result right back into Python using the underscore SQLDF variable. This interoperability means you never have to argue with your co-workers about whether Python or SQL is better. You can use both simultaneously, picking the perfect tool for every specific task. We now have the engine running. We understand the architecture and we can speak its languages fluently. But we are still missing one critical thing, our real data. Our massive sales underscore data.csv is sitting inside our Unity catalog volume, waiting to be processed. In the next lecture, we are going to dive into the Databricks file system, master the DBUtils SDK or other software development kit, and finally pull our raw CSV files into a PySpark DataFrame. And I will catch you there.